Hey everyone, welcome to this video. So today I'm talking about cloud computing fundamentals, and these slides are part of my Udemy course, that is Introduction to Cloud Computing, a crash course. If you want that course, you can reach out to me on Discord and I can provide a coupon code where you can access this course for free. So in this video, I will give you an introduction of cloud computing so that you are aware of all the concepts and some of the interview questions that might come related to cloud computing when you're applying for your job related to AWS. So let's get started and we'll see what is cloud computing. All right, so let us understand the cloud computing industry. In 2020, this computing industry was around 274 billion. It is expected to grow at a rate of 20%, almost around 19.1% CAGR, that is annual growth. And in USA alone, it is expected to grow at 18.1%. So around 60% of workload were running on cloud in 2020. It has now probably increased to around 80%. And AWS, which I'm talking about in this series, has the biggest market share, 32% as of 2020. And I think it has remained somewhat similar. So if I talk about what is the current share of various cloud service providers, so AWS is on top with 32% of market share. 19% share is of Microsoft Azure, you can see it here, and 7% is of GCP. If you are looking to go for any cloud certification, I think you should target for AWS or Azure. Now others have around 42% share, which includes Oracle, IBM, Red Hat, and all the other cloud service providers that are there in the market, including Tencent, Alibaba, etc. Now, I will give you a brief analogy of one example where a person who has been tasked to set up a data center for, let's say, an e-commerce website. Bob, our IT manager, has been tasked to deploy a web application e-commerce using traditional IT infrastructure. Let's see how Bob goes about it. So the task is to set up a traditional IT infrastructure, which means he has to build a complete data center and set it up. So the main part of any data center are the bare metal servers, which are the physical servers. This is an example image for Dell EMC web server, which is available in the market. And the biggest problem is that it can only be used by one consumer until unless you have multi-tenancy and you rent it out to other customers. But if you are using for your own private enterprise, you can only use it for your. So these bare metal servers are inserted into these server racks. So if you see here, this is a server rack, which is around 42U. One unit is of 44.55 mm high. So you can take it roughly as 50 millimeter. And then you can see this complete rack is around 42U and it comes to around 600 mm. So this rack, you install your web servers in this rack and then you connect it to a switch, which we call a top of rack switch. So once you connect to the top of rack switch, these servers are able to communicate with each other. So now let's understand what is the cost of running a data center. So you have a server room, you will require some switches and routers so you can connect your servers across each other. You will have some internet connectivity, power to run these data centers. Now, and you will also need power backup because if your mains fail, then you need some power backup to make sure that your data center is not offline. You require some cooling requirement because these data centers generate a lot of heat, and you require some software and software licenses. You require some management and monitoring applications so that you can check if your data center is healthy, if your servers are healthy, if there are any out of ordinary going on. Then you need someone to look into this complete data center. So overall, you see the focus of running a business shifts from the business logic into IT management. And that's the biggest challenge of running a data center. So here I will give you an analogy. If you are going from point A to point B, there are two ways using which you can solve this problem. First is that you buy a car, you learn how to drive, and then using your car, you start from point A and reach to point B. The second option is you hire a taxi, where you might be paying higher per kilometer, but the overall cost, or what I should say is capex, is less. So you're not putting in initial investment of buying a car, getting insurance, getting your registration, etc., and spending in skill of learning how to drive into your commuting. So this problem was solved by taxi services and then later on identified by Uber as where they are selling commute as a service. So this as a service notation is quite now prevalent in the market where you can have everything as a service, and in AWS everything is a service. So when we talk about shifting into this model where you are availing a service, it is called a service-based business. Now let us understand the other problem with private data centers. Now you set up your data center and it's an e-commerce website. Periodically you will run some promotional offers. Suppose during a festival time you have run a promotional offer and there is a huge demand. Now to match that demand, your server should scale. And the problem is that you have limited capacity of what you have bought off. So there is a limitation on how you dimension. So there are two ways you can scale your resources. The first one is increase the resources, that is get a bigger server. And the second one is get more servers. So the first one is called vertical scaling. You can think of vertical scaling as increasing the size vertically. And the second one is horizontal scaling, that is increasing the number of any resources. So if we talk about scaling in terms of our analogy, you can think of it in our analogy, you can think with an example. For example, there is an event and you have a lot of relatives and friends coming over to you and you want to make sure that you can go with them together to that event. Now there are two options. Either you buy 10 cars to accommodate all of them, or you can hire 10 taxis. Which one is easier? Obviously the second one. Now that's why whenever we need scaling, we always hire resources, which is not feasible in terms of data center because of a lot of constraints related to data and IT complexity. So that was the biggest challenge in private data center. So we used to dimension our resources according to the biggest, I would say, peak time. And you would have seen in a lot of websites that during such huge demand, the websites would go down. There would be web server not available errors, and because servers were not able to meet that demand. Now you can think of scalability. Like suppose we dimension our resources for this December period where we have festival, and you can see here we have quite good, I would say, efficiency, 80% of efficiency with web traffic reaching here and around 20% of unutilized or non-utilized resources. But what about July where we have a very low traffic, or what about you can say other months where we have minimal traffic? So this period is underutilized traffic. Just like if you bought a car and you are not going anywhere, you are just paying for the registration, you are paying for its maintenance, and it's going in vain. So that's why this is the challenge with private data centers. So now you would have understood what is the challenge with private data center. All right, to see how cloud computing solves this issue, let us understand what cloud computing is. So this is the NIST definition of cloud computing, and it might be asked in your interview anywhere. So you should be always aware of the NIST definition of cloud computing, and I will explain you word by word. So cloud computing is a model. Model means that it is kind of a template which can be used and applied to any computing services. Right? A model describes how units of computation, memories, and communication are organized, which enables convenient. Now, first and foremost, it should be convenient to use cloud computing. If you think of AWS, it's very easy to use. Everything is graphical user interface, right? If you go to Azure, everything is graphical user interface. There is command line as well, but mostly the primary interface is graphical user interface. So it's very convenient to use. Then it is on demand. Whenever you want, you can go to Azure, you can go to AWS, and you can spin up your resources. That is called on demand. It is available on network access. In case of private clouds, it is available on private network. In case of public clouds, it's available on the internet. To a shared pool of configurable computing resources. Now this term shared pool of configurable computing resources has two parts. One is the configurable computing resources. Whatever computing resources you want, you should be able to configure them. And the second is shared pool. This means that if I have X resources, I should be able to provide that resource into Y or more than X number of people. Now this shared pool of resources is very important because that's where your cost reduces. And once your cost reduces, you are able to provide it in a cheaper rate to a lot of industries and lot of users. And that's why once the computing cost reduces, your innovation opportunity increases. And that's the main reason why in past 10 to 15 years we have seen a lot of innovative companies and startups coming into the market because of the reduced cost of cloud computing. Rapidly provision, this means I can go to their website and provision a resource. It should not take 2-3 days for me to send a request for resource and then they will provision it for me. It should be within minutes or seconds, so that I know, okay, I need these resources and this is the amount of time it should take. It should not be so slow that it makes me wait. One thing is to provision it. The next thing is releasing it. It means once you provision it, you should release it as well. This is the term elasticity. That it means whenever you have some demand, you should be able to increase the resource and then reduce it when the demand reduces, so that your efficiency is always top of the chart. With minimal management effort, as I've already mentioned, that you should not require someone else to do it for you. You should be able to do it on yourself. And it has 5 essential characteristics, 3 service model and 4 deployment models. Now this is very important. It is called 5-4-3 model, and I will explain you now what this 5-4-3 model is. So 5 essential characteristics means cloud computing has 5 characteristics. And 4 deployment models means cloud computing can be deployed in 4 ways. 3 service model is that cloud computing has 3 types of various services. Broadly, you can classify every service into these 3 types. So let us understand what is 5 essential characteristics. First is on-demand self-service. I've explained most of these characteristics. The last one, measured service, is very important because unless you measure a service, you won't be able to know how much computing resources you have used and what bill you have to pay. So this is something related to electricity. And that's why cloud computing is a subset of utility computing, where utility computing means just like your electricity at home, you go to your service provider and tell them, okay, I need electricity. They would provision it for you. You pay for what you have used. Similarly, with cloud computing, you pay for the resources that you have used. Now there are 4 deployment models. One is the public cloud. That is, for example, AWS Azure, which is open to all public. Second is private cloud. For example, OpenStack or VMware, which you can spin up in your own enterprise and use it internally. Third is community cloud, which is kind of when 2 or 3 organizations or 2 or 3 entities come together and build a cloud for themselves. For example, if all the governments inside Euro region come together and build a cloud, that would be considered something as community cloud. And the last is hybrid cloud, which is the combination of above 3. If an organization has their resources in public and private cloud, that would be called as hybrid cloud. Now there are 3 service models. One is infrastructure as a service, second is platform as a service, and third is software as a service. So let us understand what these 3 service models are. So let us understand with this stack. So this is a very broad level stack that you can use to find any of the application. And if your infrastructure is managed by a cloud service provider or CSP, then this is called a infrastructure as a service. In this case, you as a user will manage your operating system, middleware, runtime library, applications and data, everything. So it's your headache. The second option is when up till runtime libraries is provided by CSP. For example, in case of Lambda, AWS Lambda, this is provided by cloud service provider and this is called platform as a service. You only have to take care of your code, that is your application and data. And the last is software as a service, where everything is managed by CSP, only you have to manage your data. So this was an introduction to cloud computing, and in day 2 we saw all these stuff. Just reviewing the checklist, I covered what is the difference between a private data center and cloud, understanding the NIST definition of cloud computing, 5-4-3 model, differences between IaaS, PaaS and SaaS, and it's up to you if you want to enroll. I've given the link in the description in this Git repository as well as the description of the video. You can sign up there, and in case you need the coupon code, just let me know and I will be happy to provide you.